Okay, we're going to go ahead and get started. It's a couple minutes after. So first off, let me introduce myself. I'm Sherwood Zern. I'm a product manager for Oracle on the Oracle Cloud Infrastructure. We appreciate everybody taking the time out from their busy schedules to attend today's webcast, Faster and Safer Application Deployments on Kubernetes and Shipa and Oracle Kubernetes Engine, also known as OKE. We are very excited to be able to share with you how Shipa is adding support for the Oracle Kubernetes Engine. During the presentation, if you have any questions during this presentation, please put your questions in the Q&A, and we will answer your questions as quickly as possible. We would want this to be as interactive as possible, so if you, as the presentation is going on, and you have questions, please post them, and you don't need to wait till the end to get an answer to your question. The webcast is being recorded, and we'll make it shortly available after the webcast concludes. Again, thank you for joining the webcast, Faster and Safer Application Deployments on Kubernetes with Shipa and OKE. This webcast will be presented by Henrik Rosendahl, who's a co-founder and chief operations officer at Shipa, and Bruno Andrade, who is also a co-founder and the CEO at Shipa. Before I turn it over to our friends there at Shipa, I'd like to give you a brief overview of OKE. Okay. So here we are. So before we get started, here's the safe harbor statement that we always have to put out there for Oracle, just so you know that we're going to, discuss it, but we're not going to make any commitments to any dates or features and that type of thing. Though we may discuss them, it's not going to be where we can guarantee, because things change over a period of time. So that's this. So let's get into OKE. So what is OKE? And before we get into talking about Shipa and where it fits inside this model, so OKE is Oracle's container engine for Kubernetes, and it is fully managed, scalable, and highly available service that you can use to deploy your containerized applications to the cloud. It is based upon the Kubernetes. It is not, there's no proprietary code in there. So if you're concerned about, well, I have deployed out my own Kubernetes, and if I want to move it to there, do I have to re-architect or rebuild or any of that? Absolutely not. You can run it right on top of OKE, because it is the same thing that you see out there in the open source. The only difference being is that we're managing the aspects of your infrastructure on top of OKE. So let's talk about it. Besides the Oracle Container Engine for Kubernetes, all the additional cloud native services being offered by Oracle. So you have, obviously, as briefly mentioned, we have OKE, then you have the OCIR, which is a Cloud Infrastructure Registry. We have Developer Cloud Services, the Resource Manager, which is a nice feature that you can upload Terraform scripts, and then it'll allow you to deploy, and it'll build out your environment for you. The API gateway, and then obviously, and then finally there we have the functions, which is also, which we know as serverless computing. Then we have, from an observability and messaging, you have the monitoring, the logging, which is very similar to FluentD. And then our streaming services, which is backed by Kafka. So it's very similar to if you were using straight Kafka. So you add all these things together, and it gives you a nice infrastructure and a nice architecture to deploy your applications on a cloud native platform. So here we have is, obviously there's this opportunity to build out many aspects of your cloud native applications. We are very open. Oracle is, at one point in time was not seen as being very open, but we have since changed that mindset, and we are now very open and take a leadership role in many areas of the open source communities. We're also a platinum member of the Cloud Native Computing Foundation and a member of the Open Container Initiative Linux Foundation. And we also are, you'll see that we have contributing quite a bit back to the open source community. If you look at FN, which is functions, the helidon.io, which provides you with Java for microservices. You have the Graal VM, and then also MySQL and Java. So going from there, then if you look at our cloud native and data management, we provide on top of OCI, you're able to deploy, and we don't restrict you as far as any language or framework. There are many different languages that you may want to deploy on top of. And then in addition to that, you have a autonomous database and then the management and security. We don't restrict users to one or two programming languages only. You have the choice to use any programming languages like Java, JavaScript, Node, Python, Ruby, Go, whatever is in your wheelhouse and your language of choice. And now if you look at from the cloud native development, we have OKE, which I briefly mentioned about it, to deploy and manage containers at scale. We also take care of the patching and upgrading your Kubernetes environments. And then also because OCIR is in that tenancy, we have very low latency as you pull your images from a registry into Kubernetes. Now let's talk a little bit about the OKE and OCI pricing and packaging. First off, if you see here, the stuff in the gray area, that's Oracle managed. The stuff in the light blue would be the customer managed area, which is really all about your application. So OCIR registry is totally free to you as a user in that environment, developer in a tenancy. So you get the OCIR totally free. You're not having to pay extra for that. And then from the master node and the backup of those master nodes, that is also free. You do not have to pay for the master nodes. You're only paying for the, excuse me, the worker nodes that are deployed inside your Kubernetes environment. And then you're only paying for those OCI resources used to run your Kubernetes cluster. So it's a very cost-effective model when you want to deploy your cloud native applications. And above and beyond the Kubernetes or the OKE and OCI, we also have the service broker, which gives you the ability to deploy very easily and quickly autonomous database, the autonomous data warehouse, object storage, and streaming. So you can be able to stand up those environments extremely quickly in your architecture. Now obviously you have to have some persistence in some areas, need persistence for those containers. So most of your applications, obviously they talk about in a microservices standpoint, they look at them as from a stateless scenario, but if you didn't maintain any kind of state, there would be nothing, there would be much of an application. So there is the idea of you do need some kind of state. So in that sense, you would be able to access from OKE. You can talk to the autonomous database. We have object storage, block storage, and file storage. And so if you look at it, there are many benefits to using those types of back-end stateful apps. And so I'm just about ready to wrap up here about OKE, because I want to give most of the time to the engineers from Shipa. So some of the recent updates and highlights of OKE we now have the ability to give you flex shapes. So you're not tied to the 2, 4, 8, 16, 32, 64, if you will, amount of memory, and also the number of CPUs. You can pick the amount of memory you want, you pick the number of CPUs you want, and so it gives you quite a bit of flexibility in that way. Also, if you know the behavior of your application, you're not paying for resources that you're not even using. We have an audit service so that you can monitor your traffic, and then also through that audit service, you can set up different events to happen so that you, as you set up these triggers, you can get notifications. And one of those things is you can actually kick off a function depending, on the different audit events. The current version that is in OKE that you can use is 1.18.10. 1.19 will be coming out shortly. And then you have Cloud Shell, which is with OKE, which is a very nice feature. With that Cloud Shell, you don't have to install kubectl, you don't have to install the OCI CLI, none of that do you have to install. The Cloud Shell will maintain every bit of that for you, and all you need to do is access it through that shell, and you're not having to download and configure a lot of extra pieces of software. And so now I'm going to get ready to turn it over to Henrik and Bruno, but I just want to say, if you remember the first slide that I put out there, this regarding Kubernetes, and you can look to see that where Shipa fits in and where their wheelhouse is, and it's up here at the app management and app deployment. And so when you look at it from the whole Kubernetes environment, you can see that this is the place where Shipa improves your life as from a developer standpoint. So with that, I'm going to turn it over to Henrik and Bruno. Let me stop sharing. Henrik and Bruno, do you want to start sharing?
Yes, appreciate it. Thank you, Sherwood, for the introduction. We are super excited to be here. I am going to give you guys a brief intro to Shipa, and then I'm going to pass the mic over to Bruno, who is going to show you how Shipa works on top of OKE. But just to continue, Sherwood, from where you left off. So Shipa is essentially an application deployment and application management platform that sits on top of Kubernetes. And so let me just explain a little bit more about what's going on in there. Bruno, can you advance the slide? So a lot of customers, as they get into Kubernetes, are sort of setting out with a do it yourself mindset. And they're looking at all these different tools that are available. I think there's probably more than 1,000 members now with CNCF, and so there's Istio and Terraform and Prometheus and OPA and Jenkins and Snake, etc., and they're getting quite excited about building their own their platform. But at the end of the day, and as time goes by, it ends up being fairly messy. It doesn't really scale every time you add a new tool. You have version issues and compatibility issues, etc. It ends up taking a ton of time putting all this together, and at the end of the day, it's not super developer friendly. And so developers are getting stuck with actually managing a lot of infrastructure-related Kubernetes tasks, and that's really a part of what Shipa helps alleviate. So, as a sort of alternative to do it yourself, there are of course sort of these platforms. They could be either Red Hat OpenShift, it could be VMware Tanzu, And that seems to be sort of a nice idea from the outset, because it's sort of a packaged solution. It ends up, however, being fairly expensive. It is, for the most part, very resource intensive. You will have some vendor lock-in, and it's not really flexible because you're not actually running native Kubernetes. You're running sort of a pre-described version of these tools. And you end up lacking the ability to extend support for other platforms, for other solutions out there as you see fit. So, for the most part, people go back to Kubernetes do it yourself. Of course you can do this, right? This is sort of like, we're on a journey. We're going to build this in-house platform. It's all going to be very exciting. And so you sit down and you come up with this sort of laundry list of services that you would like to provide to your developers. And this is just sort of a subset of it, but of course you need RBAC for security. You need CI/CD pipeline integration. You need observability and security. You need storage, registry integration, etc., etc. So there's like a lot of services. And you sort of start developing your own, in-house platform. On day one, all of this looks pretty good. You sort of deploy your first app. You have your first sort of subset of services. You can see here we just took 3 services, and the developers are pushing the code to Git, and from Git, the platform operator is making all this work and deploying to an on-premise Kubernetes cluster or some cloud cluster with OKE. However, as the number of applications grow and time goes on, in this case here a year later, this becomes more and more complex. And what was supposed to be sort of a neat in-house platform is now a complete mess of YAML files, Terraform scripts, Helm charts, etc., etc. And there's a lot of people involved. And every time you're adding new applications, it's just getting more and more sort of unmanageable. Developers are getting stuck with infrastructure-related tasks. The platform operator, the DevOps guys are trying their best to sort of glue it all together and make sure it's available on the appropriate production clusters. And the SREs are having a tough time both monitoring, observability and also maintaining a secure platform. And so essentially, this is really what Shipa is trying to address. If you look at it, a lot of our customers are spending up to half of their time just building and maintaining these various scripts just to make things sort of deploy, not to mention, manage the life cycle of an application. Every time you add a new cluster, a new application, you're increasing the complexity and you're driving some of that complexity into the hands of the developers, which is slowing things down, and developers are getting frustrated with infrastructure-related tasks for Kubernetes. It's of course really hard to enforce security across various environments, and so that's fairly disjointed from a centralized perspective. Observability is tough because you have so many different infrastructure components that all sort of as a collective sum makes an application. So actually understanding where the slowdowns are in your environment is getting really tough. And a lot of this, as I mentioned in the beginning, is coming back to haunt the developers, and we're starting to see like real sort of Kubernetes fatigue out there amongst the developers. So with that, let me pass the mic over to Bruno, and he can talk about how Shipa helps alleviate some of these Kubernetes grievances.
Yeah, no, sounds good. Thanks, thanks for the intro, Henrik. So I'll talk a little bit about Shipa. I won't spend much time on slides, so I'll go through them all many times. That's what people really also want to see, how it works, actually the look and feel of it. But a little bit of a background before we jump into the software itself. How Shipa works is it works different than a PaaS, right? As Henrik mentioned, Shipa didn't try to build a platform as a service. We don't want to lock you down into one vendor, one cloud, and so on. But we wanted to make sure Shipa is an application management framework that can fit on top of Kubernetes and OKE. And when you think about it, the role of the platform operator, like Henrik mentioned before, instead of you having to build a bunch of YAML files, Terraform scripts, and so on, what you're building now is what we call a framework. And this framework is defined by the platform operator, which in some organizations they call it a platform engineer, some organizations they call it a DevOps team. So it really depends, but you have a platform person defining what we call a framework. And that framework is really abstracted from the Kubernetes infrastructure itself, but it's focused more on the application side, where you now as a platform operator, you are defining things such as the RBAC, so which teams can actually deploy applications and consume this framework. You're going to define things such as observability, third-party integration. So this framework, for example, can offer native connections to services, maybe such as RDS, MongoDB, to the applications deployed using it. You can define network policies, for example. So by default, let's say every application deployed using this framework gets a zero trust type of policy. So no ingress and no egress allowed to my applications by default. You can define a registry control, such as where my applications are actually coming from. And last but not least, security scanners and vulnerability. So let's say every app deployed gets this level of security scan at the application code level. And these are the exceptions, if any, that I want to allow to applications when security scan is executed. So you define all that as an application, as a platform operator. And once you define that, if you go back to the previous scenario that we had with your developer, you have your Git source of repository, GitHub or GitLab. You have your CI platform, either a centralized CI pipeline or multiple pipelines. And you have the same scenario that we had before, but now instead of you having to build that glue and bridge between your CI pipeline and the Kubernetes infrastructure, what you have is you have the frameworks that you build as a platform operator tied to the Kubernetes clusters, and the CI pipelines now are pointing to these frameworks instead. And a few things happen when you do so. One is as application code is deployed, the frameworks are then responsible for running all the security scans, enforcing controls and policies, applying network policies, making sure the application code is coming from a certified registry, for example. So you know that in your organization, the applications deployed using that framework are following the prerequisites from a security and controls perspective. The developer side, now, instead of the developer having to create deployment sets, ingress rules, and so on and so forth, and learn about it, the developer actually, they don't have to do anything related to Kubernetes. They're pushing their application code, I would say their Node.js apps, Python or Java apps, and the frameworks are going to be responsible for automatically creating these objects and deploying. So ultimately, what you are doing is you are enforcing controls and policies from an organizational perspective, at the same time that you are improving developer experience and speed, and increasing the observability and support of your applications. I'll go towards the live demo, but it would be great to see if maybe from if there are points that that folks wanted me to cover to drive it more in an interactive way instead of me just going through the other platform.
Yeah. So one of the things, Bruno, is when you're talking about setting up Shipa and putting it on top of OKE. So how do you create these pools on top of OKE? How would you go about doing that? And why is that better than the old standard way? Okay, I'm in OKE. This is how I create my node pools and stuff. How is that different when I use Shipa, and why is that a better approach?
That's a great question. So everything inside Shipa is driven by the frameworks or pools, right? The frameworks inside Shipa, they're called pools. And you can create these pools or frameworks using both the dashboard, or you can use the CLI to do it. Now, to your point on why it is better to drive it from Shipa is, for example, when me as a platform operator, I'm creating the controls and guardrails that I want it to be applied to my application. Usually I would have to try and communicate with a third-party security scan. I would have to learn how to automate and glue things with YAML and Helm and custom scripts around network policy, around RBAC for team provisioning. So it's very segregated and very separate. So it's really hard for me to build control, especially at scale. So when you're building it with Shipa and the pool, here's an example. I'm doing it from the CLI, and I can do the same from the dashboard. But I'm defining, for example, how much CPU and memory my applications deployed using this pool can consume, the level of security scan, which teams can consume it, how many apps they can deploy, and so on. And once you define the pool or the framework, you can define many. Let's say for your development environment, maybe you don't need security scan, or you have a very relaxed network policy. But for production, you have a very specific network policy that you want it to be applied, very specific security scan. So you can define multiple frameworks or multiple pools with different level of security and controls. And you can attach it to your different Oracle Kubernetes clusters. So in my example here, I have 2 Kubernetes clusters where I treat one, for example, as a developer cluster, maybe, development cluster, and the second one is as a production cluster. And I can tie, for example, my OKE dev pool that I created as a platform operator to the first cluster. And you can see that the OKE dev, for example, I don't even have scans active for this pool. And same way for the production OKE pool that I have, for example, active scans. So you can start attaching and mapping the different pools that you have to the different OKE clusters. So now you as a platform operator, you know that everything that needs to be enforced and controlled are enforced and controlled across multiple clusters for your developers. Does that make sense?
Yeah. So when you, what exactly am I scanning here? What exactly is that being? Am I scanning my images for security vulnerabilities? Is that what's being scanned here? Is that when you say, scanning is enabled? Is that what I'm doing here?
Yeah, there are 2 levels of scans that you can enable. The application code level, so it's scanning your application code for vulnerabilities, is one level, and the second level is your image. So you can enable both or one of them, and you can say, for example, for my production pool, these are the only components that I want to ignore as vulnerabilities, or if you want to list the specific CVs, you can list that here as well. But it's a scan of both the application code and the application image layer level.
Okay. So one of the things that I, as a developer that we get into a lot is network policies. Mm-hmm. And you're dealing with these policies and you're trying to, set them up to, either create a zero trust network, make, just across the board validating, making sure that my application is protected. So how would I do like that in Shipa? Would I need an additional add-on, or will Shipa handle that for me?
Shipa handles that for you. So Shipa basically connects to the ingress that you have installed in your OKE clusters to enforce the network policies for your application. That can be done at 2 different levels. One is at the pool level, for example. So your operator can set up at the pool level saying every app deployed using this pool gets zero trust. Or the second option is, for example, from the dashboard. If I come in here and I say one of my apps, I can say network policies, and I can set up my network policy and say, for this application, for example, I only want to allow applications from this pool, Shipa pool, to connect to my application. Or if I want to go more specific, I can say applications within the Shipa pool, but only this application can connect to my application on port 80, for example, 8080, using TCP. So you can define that either at the pool level or at the application level. And once defined, you actually get to see the traffic that is coming into your app directly from here. So you can see for my production app too, for example, I have traffic coming from my Mongo service and from my dashboard. coming through the ingress through the Shipa pool. So you have visualization and observability of what's happening at a network policy level as well.
Okay. Now, is this these network policies, are they namespace based, or can it be, because network for Kubernetes, the policies are are namespace only. You have to define it for a namespace. Can you set these policies at a higher level so they're not at a namespace? And then how does that work with Kubernetes network policies?
Yeah, that's a good question. So the network, so taking a step back, every pool that you create on Shipa or framework, that pool or framework on Shipa, it's going to create a new namespace in your cluster. Or you have the option of, when creating the pool and tying the pool to your OKE cluster, you can say, I want this pool to actually map to a namespace X that I already have in my cluster. So when you come in here and you see here, for example, rule 1, that it's targeting at a pool level. Basically what this is targeting at the namespace level. So if I just define here, I can say only applications in namespace called Shipa pool can connect to my application. So basically this is at the namespace level that you see. But Shipa allows you to go deeper and say, well, for this application prod 2, I want a specific application called movie service, for example, that is inside my namespace Shipa pool to connect to my app using port 8080, for example. So you can go at a high level, at a namespace level, or you can start down at a level of saying this specific app is the only one that can connect to my app on this specific port. Or if you want to go even further down, you can say this is the pod or the namespace or the IP block that I want to allow to connect to my app. So you can go from a very high level to a very detailed network policy application here without knowing Istio or without knowing traffic, for example.
Okay, great. So, with OKE, I only pay for my compute resources. So if I put Shipa on top of this, how is that going to increase or potentially increase my overall cost? Is this a significant, or is it minimal that I probably wouldn't even see the difference?
That is a great question. So Shipa itself doesn't add any cost to your OKE cost. So Shipa has its cost based on a per user base, for example, on the monthly price per user base. But once you have Shipa and you install Shipa in OKE, which you can do using, for example, a Helm chart, install Shipa. Shipa itself won't add additional services to OKE or won't increase the services on OKE. Of course, it does consume a little bit of resources, but the resources are mostly to control your apps. So it won't add anything additional from a service perspective to your OKE costs.
Okay, now I missed something about the cost. You say it's per user? What did I miss?
That is right. So from a Shipa perspective, the costs are on a per user base. So if you're a developer or a DevOps, for example, using Shipa, Shipa is charged today on a user seat base.
Okay. So there's no runtime cost. So like, I have my application, it's out there running, and there's, 2,000 users going through my system. I'm not being charged for the 2,000. It's just the developers that are using.
Exactly. That is perfectly right. Yeah.
All right. Okay. So what kind of, does it give me additional observability into my cluster? I mean, we talked about network policies. We've talked about, setting up these pools, and also being able to see the ingress traffic once I set up these policies. So is there other aspects, hey, I want to be able to audit to make sure I have the right policy set up, or I haven't overlooked something, and is there ways to audit? And then even beyond that is, hey, I want to be able to, I deployed something, but I now need to roll it back. Does Shipa help me is from a developer standpoint in rolling back something that I just deployed?
Yeah, it definitely does. So if I take it from a developer perspective, let's say I have Shipa and I have OKE now, and I want to get started. My platform team created the pool, attached it to an OKE cluster, and I was given access as a developer. So for example, here on my terminal, I have a simple Node.js application. I have no Kubernetes objects whatsoever. I don't know if it's running version 119 or version 118. Me as a developer, I'm just given access to Shipa to a Shipa pool, and I'm deploying my Node.js app. So I would just say Shipa app create, for example, OKE1. I would say it's a Node.js app. I would say it's the Shipa team admin or whatever team I'm part of. And I'm going to choose the pool that I want to deploy my application to. So let's say if I was given access to OKE Dev and OKE Production, I can choose where I want to deploy or create this app. So I would say OKE Production, for example. Great. And now I can see if I go to my application here, if I see OKE1, it's idle because I haven't deployed anything. But I can just say Shipa app deploy, and the deploy can be done from my CLI as well as from my CI perspective. Shipa app deploy OKE1, and I'll deploy my code that it's here. While the deployment is happening, you can see that me as a developer, I don't have the need to create deployment sets, ingress rules, and so on. As I deploy my application code and point it to that pool, the pool will create everything automatically for me. And to your point, as the application is deployed, we try to present everything on a workflow level. So you can see how your application is actually performing at the application level. So you can see status codes, requests per second, response time of your application. You can see how much resources your app is consuming. You can see the units of your application and the status if there's anything with error or running. You can see geographically where your application units or your containers are running in case you have a multi-region type of cluster. From an audit perspective, like you mentioned, you can see when the application was created, who created the app, when it was deployed, if the application scaled up or down, and you can see the log associated to that action. You can also see the deployments that happen, and in case, let's say you've done 10 deployments, you can roll back directly from here based on the Git operation for that specific version. So Shipa redeploys and rolls back everything for you automatically. You can see all the security scans that were executed, and you can see if any vulnerabilities were found and ignored based on the pool configuration that the platform team created. And you can see integrations into incident management systems such as PagerDuty, Ops, Genie, Victor Ops, and others that you can set up so any activity that happens to your application can emit or create an alert in those systems. So we try to set up it on a workflow level that you as a developer, both as a developer and a platform operator, you can easily see what's happening to your app. And last but not least, as well as you have here my application code that I deployed, for example, my Node.js application, for example. Me as a developer, I just deployed that application code, but now I can see all the containers that Shipa created for me automatically in my OKE cluster. I can see the images that were deployed. I can see all the secrets, services, my pods, my ingress rules, all the way down to even commands that my app is executing every time it is running. So both me as a developer or an SRE, I can clearly see the architecture of my application. I can see the performance, and if there's anything wrong, I can quickly map and troubleshoot that. So Shipa improves that observability level for application developers and SREs as well.
Oh, cool. Now, you probably get this question quite a bit, but as a developer, can I download a copy of Shipa, work with it, and what's the, I don't know if you have an open source version or if you have a version that you allow for a trial. Do you have such a thing as that? So that as a developer, I can play with it and that kind of thing.
Yeah, no, that's a great point. We have a website called learn.shipa.io, which is basically where the documentation is located today. And you can see information on how to get started with Shipa and deploy. Shipa has a free version, a free forever version that you as a developer, you can already start today, or a platform engineer, you can start and install in your OKE cluster. So Shipa itself is not open sourced. Shipa is a closed source, but you have a free version. What Shipa does have is a project called Catch that we open source, which is the deployment part of Shipa, the application deployment piece. We open sourced as a separate project, and we maintain that. We're happy to have developers and DevOps teams to take it for a spin, report any issues, help us with the roadmap, and so on, and participate. But Shipa, you have a free version that you can get started with using a Helm chart. You can install in your OKE cluster. And thecatch.io is the deployment piece that we open source from Shipa.
Oh, okay. Super. Yeah, I didn't know about the catch.io. I had seen Shipa, but I didn't know that you had that open source. That's very nice. Now, I saw you have a lot of graphs that I can do stuff from a UI. But does Shipa also have a CLI that I can use if I want to do stuff from the command line? Can I just do things from the command line?
Yeah, definitely. So Shipa has a very detailed CLI. I would say that you can control everything from an application perspective. You can perform application deployments, quota control. You can create the pools or the frameworks from the application. You can move application between pools as well. So let's say you have a pool for development that is pointing to one OKE cluster, and you have another pool that is called production on another OKE cluster. You can actually do a Shipa app move, for example, between the two different pools and the two different clusters, and Shipa will do the move. You can manage certificates. So Shipa has a very detailed CLI available that if you prefer to use the CLI, that is a resource available to you. And in addition to that CLI, we also have a Python library component that you can use to, let me make this bigger. You can use that to connect to your CI pipeline. So you don't need to deploy your applications and create your apps only from the CLI or the dashboard using Shipa, but you can connect Shipa to your CI pipeline. So you can do a Shipa install, a pip install Shipa CI, for example, and directly from here do an application deployment to your Shipa. You can do a straight deployment, a blue-green, or you can do a canary deployment, for example. So if you do a canary deployment today using just, I would say, OKE and Istio, you would have to learn about Istio, ingress rules, and all that stuff, create the YAMLs. But using Shipa and OKE, you just have to use these three flags, and you get your applications deployed. So you have Shipa CLI, you have dashboard, and you have the CI component that you can connect to your CI pipeline to create a pool, connect a cluster, create applications, deploy applications, and so on. So you have full control from different aspects.
Okay, great. So we have about 15 minutes left, and I don't want to monopolize everybody's time with the questions and stuff. So if you have additional questions, please put them in the Q&A, and we'll definitely make sure that Henrik and Bruno get those answered. So far, we've had a fair number, and I think they've all been answered. But if you have additional ones, please put those questions in there, and so you can get the most out of this session. Because appreciate Bruno and Henrik coming here and taking the time to do this. So Bruno, I'm gonna leave it up to you if you want to have a wrap up, or Henrik wrap up on Shipa. Let's see. Oh, here we have. So here's a couple of them. Bruno, I don't know if this is, do you have any use case of Shipa over OCI? Use case of Shipa over. Make sure.
OCI, yeah, using OKE. We're starting to see folks taking it for a spin with OKE. I would say the OKE service is the connection to the OKE service is fairly new. So we're starting to see folks taking it for a spin right now.
Okay. Can we safely say with Shipa we can replace developer cloud services?
That is a good question. I would need to look in more detail around the developer cloud services to be able to answer that. But I would say Shipa's aim to basically help the developer to focus on the application code, even if they're delivering on OKE, which is Kubernetes at scale, while enforcing the security controls and guardrails across network policy, security scan, RBAC, and others. So I would have to look in more details to be able to give an answer to that.
Okay. And how does Shipa fetch its metrics? For example, CPU. How do you grab those metrics? And is that an exposed API that others can use as well?
Yeah, so that is a great question. So the way we expose the metrics are basically in two different ways. One is the transactional information. The transactional information for your application, we're actually getting it directly from your ingress controller. So let's say Istio, for example, that you have installed in the OKE cluster. That's how we can get that, and we're using Prometheus on the backend to expose these metrics and charts. You can connect that to an external Prometheus that you have, as well as you can export that to, let's say, Datadog or New Relic, for example. Now, from an application resource consumption perspective, such as CPU and memory, that the question was more directed at, we actually deploy a sidecar in your Kubernetes server, in your OKE cluster, to gather the metrics related to the application. So we are not getting node level metric, we're getting application consumption metric from your cluster. So that's how we do it.
Okay, thanks. Next one is, for logging, does Shipa persist the logs from pods using Elasticsearch?
That's a good question. We have connections into different services. So from a simple kind of answer perspective, you can get logs directly from here. For example, OKE1, you can see the logs that are that your pods are producing. You can export that log to Elasticsearch or Logs.io and other connections that we have as well in order to persist the log post-application deletion, I would say. So there are different options in terms of external integrations for log persistency or Datadog and so on.
Now, is there any, and the reason I'm asking this question is because I ran into this with another vendor, and I won't go into who it is, but is there any issues with Shipa running with any specific CNI, such as?
No, I think today, from an OKE perspective, if I'm not mistaken, and any folks, please feel free to correct me. I think OKE advises or has documentation around Calico as a CNI perspective to help also with the network policies and so on. And Shipa supports Calico very well. Most of the clusters that we use today across different users are basically using Calico as well. So we don't have any issues with that.
Okay. All right. Just verifying.
Yeah,
it says, does Shipa deal with vault secrets?
It does, actually. So you, as a developer, you can inject vault secrets directly into your application. We have a file that is called shipa.yaml file that you can use as a developer. You can use for a couple of different things. One is you can use it to run hooks when your application is being built and deployed or restarted, for example. You can use the Shipa YAML file, which it's good to know is optional. But you can use the Shipa YAML file also to run health checks in your application, such as here in the documentation. You can run a health check as a developer every time your application is deployed. Run a get into this path, and if you don't get a 200, basically roll back my deployment. And third, going back to the question, is also inject vault secrets into your application as well. So we do support vault secrets, and in addition to vault secrets, you can also define environment variables directly at your application level, directly from here and from the CLI as well, in addition to vault secrets.
Okay. All right. We have about 8 minutes left. If anybody else has any other questions. What just as a side note, what, I think we touched on it briefly, but have you measured what the actual overhead of Shipa places on a cluster? Is it 3% additional compute resources, 5%, 1%? What additional overhead does it place on your cluster?
That's a very good question. I know the engineering team did the task quite extensively, but I don't have the question from top of my mind. So instead of giving a wrong number, I'd rather just send to folks that separately and get that number from my engineering team.
Okay.
But it's definitely nothing like 10 or 15%. It's definitely below that, but I can definitely get you a number, the exact number.
All right. Thanks, Bruno.
No problem.
Any other questions before we wrap up? Oh, here we go. Does Shipa get deployed on Cube system namespace? Since OKE has RBAC enabled to restrict deployment.
Oh, that's a good point. So the way Shipa is installed today, Shipa is deployed to, you can actually choose the name, but of the namespace, but if you follow the documentation, we will ask you to create a namespace called Shipa-system, and everything related to Shipa will be created, will be deployed inside that Shipa system namespace. That's for the cluster where Shipa controller is installed. Now, every other OKE cluster that you add to Shipa and the Shipa pools, Shipa will also create a namespace called Shipa inside that cluster that you're adding to the pool. And all the objects and deployments are going to happen in that Shipa namespace. So we don't use the Cube system namespace for deployment.
Okay. And stuff's not deployed on the master, correct?
That is correct. Yep.
Right. Okay.
Yeah. We're trying not to get your masters down, at least.
Yeah, I mean, because on OKE you don't have access to the master, so.
And I think that's the case we see with most of the clusters. Users are not really deploying stuff in the master unless they're playing kind of locally from a development perspective in your laptop. But the real life scenarios, I would say, we don't see that happening for sure.
All right, and we'll make this the last question. Can Shipa scale node pools or upgrade them?
That's a great point. So Shipa will not scale your node pools from a node perspective on OKE. So for that, we rely on OKE itself for the scale up or down of your nodes, of your physical nodes. What Shipa does scale for you up and down is the number of pods and containers for your applications based on utilization if you want. So that Shipa can help. So Shipa focus primarily in the application layer level, and we rely on OKE for the scalability of your nodes. So as a developer, I'm only concerned about my applications.
All right. Thanks, Bruno. Well, I think we'll wrap up this session. First off, I want to thank Bruno and Henrik for attending and taking time out from their schedule, but also thank the attendees for coming to this useful demonstration. The session has been recorded, and we will make it available within the next few days. And if you have any questions after the session is over, feel free to contact the speakers directly. And here, let me give you a couple additional links here. Here we go. So, Bruno, can you stop sharing, sir?
Yeah. Stop sharing. There you go.
Thanks. So here's some additional links for those. And again, these slides will be made available to everybody and the recording. So if you, again, we thank everybody for attending. We thank you for taking the time out from your busy schedules. And we thank Bruno and Henrik for doing this. And if you have any questions, please feel free to reach out to any of us, and we'll be more than happy to get you answers to your questions. Again, thank you very much, everyone.
Thank you, folks. Appreciate the opportunity and the time.